Continuing our discussion of neuromuscular blockers, we'll talk about succinylcholine, which is our only depolarizing neuromuscular blocker. I think we showed in the last video the structure of Sux, which is this entire molecule. Acetylcholine would just be this top part here, and then the succinylcholine has this mirrored on itself with an additional 2 methyl groups here and here. We showed that Sux works by binding to these acetylcholine receptors. So if we have Sux in this synapse, it will bind actually to these postsynaptic acetylcholine receptors for the most part. This will cause a brief period of local depolarization with sodium coming in, calcium coming in, and then potassium leaving, increasing your extracellular potassium concentration. This spreads to our sodium channels, our voltage-gated sodium channels, which will allow depolarization ultimately at the voltage-gated calcium channels, which will allow calcium to come out of your sarcoplasmic reticulum through the ryanodine calcium channel. This produces muscle contraction, or the fasciculations that you see, but then quickly this whole process is inactivated. So after the sustained attachment of these succinylcholine molecules to your receptor, this receptor itself will inactivate and no longer respond to anything attaching to these receptor sites. And these voltage-gated sodium channels are also going to be inactivated and not let any more sodium come through to depolarize your cell membrane. The net effect of this is that you will stop your calcium release and you will cease muscle contractions, getting flaccid paralysis. It takes about 45 to 60 seconds for this inactivation process to happen, and you can intubate after you see the fasciculations, because you know that the patient will have the flaccid paralysis after that point. The duration of action is about 7 to 10 minutes, and you will slowly regain the force of muscle contraction as the time has gone on. Keep in mind that 7 to 10 minutes of paralysis is still enough to desaturate and run into issues with oxygenation if you are in a can't intubate, can't ventilate situation. So if you anticipate that you're going to have issues securing the airway or even ventilating a patient, succinylcholine will last long enough to give you issues with brain injury or arrest. Sux is metabolized by this enzyme called pseudocholinesterase. Which is in the plasma. So for it to be metabolized, it has to leave the synapse into the plasma where it is degraded. Now this is also called butyryl cholinesterase. So you may hear this referred to as pseudocholinesterase or plasma cholinesterase or butyryl cholinesterase, and they all mean the same thing. This is in contrast to acetylcholinesterase, which would be found in the synapse and would very quickly, within about a millisecond, degrade any acetylcholine that's in the synapse. So acetylcholinesterase does not work on Sux and instead needs to be broken down by pseudocholinesterase. This is important because you can have absolute quantitative or qualitative deficiencies in your pseudocholinesterase. And if you have a deficiency in the only enzyme that breaks down your succinylcholine, then you will have a longer duration of action. And actually, up to about 5 to 8 hours, depending on what dose you've given, if someone is homozygous for a mutation in their pseudocholinesterase gene. We can measure this in people who we are worried about. So if you have a family history of someone having prolonged neuromuscular block with Sux, you can send them for a Dibucane number test. So Dibucane number. Dibucane is a local anesthetic that they just use to test the function of pseudocholinesterase. Dibucane inhibits the function of normal pseudocholinesterase by about 80%. So if you have normal genes for pseudocholinesterase, therefore making normal pseudocholinesterase, your Dibucane will inhibit about 80% of that function. Instead, if you have abnormal genes for pseudocholinesterase, the homozygous mutation for that will give you a Dibucane number of 0.2, meaning that the Dibucane is only inhibiting 20% of the function of this mutated pseudocholinesterase. And these are the people who will have very long duration of action of succinylcholine, 5 to 8 hours after even a single dose. You can be in the middle too, so have a heterozygous mutation, and then you might get a Dibucane number of 0.5, somewhere in this range between 0.2 and 0.8. And then your duration of action of SUX will be prolonged, but maybe only about 2 to 3 times normal. SUX is clearly something that we'd want to avoid in these people with abnormal pseudocholinesterase. So we'll talk about other contraindications to SUX. These are important to know because if you want to give someone SUX, you should always know if they have any important contraindications. The first being hyperkalemia. And this is because when you give succinylcholine, the normal response is to increase your plasma potassium by about 0.5 millimoles per liter. And that happens because when the SUX binds to your acetylcholine receptor, you have potassium leaving the cell. And more potassium leaves when you bind SUX than would normally happen when you just bind acetylcholine to these receptors. When you start with a high extracellular potassium, something like 5 millimoles per liter, and you further increase that by another 0.5 millimoles per liter by giving SUX, you may enter hyperkalemic arrest territory. So that's why you don't want to give succinylcholine to people who are hyperkalemic. The next contraindication is related to this, which are those people who are at risk for an even higher increase in extracellular potassium when you give the SUX. And so these are the people with more acetylcholine receptors. So if you have increased synaptic or extrasynaptic acetylcholine receptors. That's because if you have more of these acetylcholine receptors, so let's add some. This is an acetylcholine receptor, so is this. When you have binding by your SUX to these receptors, you'll have even more potassium leaving the cell. So you will further increase your extracellular potassium concentration when you have more acetylcholine receptors. This typically happens in people who have an upregulation of these motor end plate acetylcholine receptors, like after a stroke, as a compensatory mechanism because there is less motor information coming down from your motor neurons. So if you have upper motor neuron lesions in general, muscular dystrophy, if you have a crush injury, or prolonged immobility, or importantly, this comes up, burns more than 24 to 48 hours after. So starting 24 to 48 hours after a burn is when you're concerned about there being increased acetylcholine receptors and then a pronounced hyperkalemic response to giving SUX. SUX is a known trigger of malignant hyperthermia. So if there's a history of malignant hyperthermia, you will not be giving SUX. And of course, like we talked about above, the pseudocholinesterase inhibitor deficiency, that would be unwise. Now, some side effects, so not necessarily contraindications, but things to be concerned about when you're giving the succinylcholine, these fasciculations that you see will lead to myalgias. So to prevent this, you can give a defasciculating dose of a non-depolarizing neuromuscular blocker. So if you give a small dose, like 0.03 milligrams per kilogram of rocuronium, the non-depolarizing neuromuscular blocker, you can decrease the intensity of that initial muscle contraction, and that will decrease the myalgias. Giving NSAIDs will also decrease the intensity of your myalgias afterwards. Remember that your autonomic nervous system uses acetylcholine as a neurotransmitter. So if we're giving something that is able to act on acetylcholine receptors, then we should expect some effects on the autonomic nervous system. Acetylcholine is the neurotransmitter for the presynaptic ganglion in your sympathetic nervous system. So if you're stimulating those, you could potentially get tachycardia. So fast heart rate from stimulating your sympathetic nervous system by stimulating those presynaptic ganglion. And then the thing you'll see more commonly actually is bradycardia, especially in children or people with high resting vagal tone. Your parasympathetic nervous system uses acetylcholine for its pre- and postsynaptic ganglions. So this is from stimulation of the parasympathetic nervous system. And you actually have to pre-treat children with an anticholinergic to prevent bradycardia because it's such a reliable response when giving succinylcholine. You can rarely encounter anaphylaxis with Sux, so about 1 in 7,500, relatively rare. And then you can get this paradoxical masseter muscle spasm with Sux. So instead of your jaw muscles releasing, you can get spasm, where your jaw is clenched shut and you cannot open the mouth. This is also called trismus. Luckily, this is quite rare, less than 1%, even in the populations that are more likely to get it, like children. You would frequently see this in someone who has malignant hyperthermia as well, but having masseter spasm on its own does not mean that you have malignant hyperthermia. I think this is just an important side effect to be aware of because it is very counterproductive to intubating someone. So always in the back of your mind, consider what your plan would be if for some reason the person ended up with masseter spasm rather than relaxation. In terms of monitoring the effects of succinylcholine, this is not as important as monitoring your non-depolarizers because typically, in absence of anything unusual going on, you will have this relatively short duration of action. So you will have given the Sux and pretty reliably after about 10 minutes, their muscle function should be back to normal. But the neuromuscular block that you get from it can exist in two forms, the phase 1 and the phase 2. So for measuring neuromuscular function, we will often use the train of 4, which is simply just 4 stimuli applied to a nerve, and we watch for the corresponding muscle group contraction. So there will be a contraction response to this stimulus, and this, and this, and this. Now, initially after giving Sux, you will be so weak that you will have no response to any of these stimuli, which makes sense. But slowly, so several minutes after giving your Sux, you will regain some of that muscle strength and you will see twitches. Let's say that your normal response is a twitch of this amplitude, so higher, but a couple minutes into giving Sux, you'll have these low amplitude twitch responses, and they are all the same height. So we'll have decreased amplitude and no fade. That is to say that they are all the same height. So that is your phase 1 block, which is the normal block that you'll see from succinylcholine, in that 7 to 10 minute duration after you've given it. You will really only see this phase 2 block in circumstances where you've given too much succinylcholine. So maybe for some reason you've decided to run a Sux infusion, or you could get this with redosing Sux multiple times. I don't want to talk about this too in depth, but basically you'll end up with the same response as if you had given a non-depolarizing neuromuscular blocker. So same as non-depolarizing neuromuscular blockade. And this is with our train of 4, 1, 2, 3, 4 stimuli, we will get decreasing amplitude of our muscle contraction. So this is fade. I will talk about fade in the video about the non-depolarizing neuromuscular blockers, but just briefly, if you give way too much succinylcholine, it will also start affecting these presynaptic acetylcholine receptors, and then will affect the readiness of these other vesicles from releasing acetylcholine. So you'll block this and get less acetylcholine released, therefore less amplitude of subsequent muscle contractions. That's only with your phase 2. That phase 1 block is everything we talked about on the motor end plate side. Then as less and less of these acetylcholine receptors are inactivated, you will slowly regain your muscle strength, and your train of 4 will return to normal amplitudes.